10.4 here, we're going to look at common logarithms. And basically a common logarithm is when the base is 10. So when you see the log of x and there's no base written right down here, that's understood to be the log base 10 of that, in this case x. It's kind of like when we have x and we say what's the power on it, it's understood to be a 1. Well, if you just see the log of something, that's base 10, which is going to be the key on your calculator, and we're going to use the calculator here in these first couple examples. So this really means the log in base 10 of 6, which is your calculator button. When you see the LOG button, that is base 10 logs. So we're going to use the calculator here to find this out. So if you look on, and you can do this with me, let's go to the calculator. I'm really using the LOG button. We did a little bit of this in the last lesson, but that is base 10. So the log of 6 is what we're looking for. And we're going to go to, I'd go to 3 or 4 decimal places. In my notes here, I've gone to 3, so we're going to say it's about equal to 0.778. And let's go to the next one. Now, think about what this means. If I was really, before I move on to the next one with the calculator, if I was really looking for what this means, remember the empty box stuff we did earlier. This really means 10 to what power is equal to 6. Remember, that base to this exponent is equal to 6. Now, because we rounded this off, but if you actually did 10 to the 0.778 power right now on your calculator, you should get approximately 6. Now, the more decimal places you go, the closer you would actually be to 6. So the calculator is figuring out what the log in base 10 of that number is. 10 to what power is that? That's really what it means. So if we go to the next one, really what this means is, this is base 10. 10 to what power is 0.35. That's really what the calculator is going to tell us. So if we go grab the calculator, we want the log, so LOG, which is right there, of 0.35. And it's negative 0.4559. I'll go to 4 decimal places on this. So this is equal to negative 0.4559, approximately. We do round it off. Okay, I would suggest probably 4 decimal places would be best as you go through things here. Now, let's go on to the next example. So that's just getting familiar with the calculator a little bit and that base 10 log button on there. All right, we did some of these earlier when we could write these two things with the same base. In other words, if you had 5 to the x equals 125. I'll just give you an example from what we did earlier. Back in the first section, or second section I think it was, we wanted to try and write 125 with a base of 5. Well, 5 to the x is 5 cubed, and then we could just set that equal to that right there, so then x was 3. Sometimes this number right here, sometimes that number, in this case 125, okay, can't be written with this base. If you notice over here, can I write 62 with a base of 5? You can't do it. So you're going to use logarithms to solve this equation. Okay? And again, I want to caution you on 5 to a power of x equals 62. Doesn't mean it's not the same as 5x equals 62. I can't divide by 5 here to figure that out. I'm trying to figure out 5 to what power is 62, to what approximate power, and we're going to go to a few decimal places here. So what we do is we're going to take the common log of both sides. Here's what I mean by that. I have 5 to the x equals 62. We're going to take the common log, LOG log of both sides. So I'm going to have the log of 5 to the x equals the log of 62. Just like if you add something to both, you got to do it to both sides to maintain the balance. If we're going to take the log of one of the sides, we got to do it on the other side also. Now, think about your logarithm rules and properties. the log of something to a power. That power comes down in front. It becomes x times the log of 5 equals the log of 62. Remember, if you had the log of something to a power, the power comes down in front and is multiplied by the log of that. Well, now, how do I solve for x? I got to undo multiplying by the log of 5. So I don't divide by 5, I divide by the log of 5. Notice I haven't even reached for my calculator yet. I'm going to get the x all by itself first. Now, I'm going to do this on my calculator. So I take the log of 62 and I divide it by the log of 5. So log 62, and I'm going to hit equals in between, and I would suggest doing that. And now you want to take that answer and divide it by the log of 5. Okay, instead of trying to do it all in one step. Find the log of 62, leave it in your calculator, and then divide by the log of 5. And we're going to go to 4 decimal places, so it's about 2.5643. So x is approximately 2.5643. So if you actually took your calculator and did 5 to the 2.5643 power right now, you should get very, very, very close to 62. Obviously, the more decimal places we went to, the closer that would be. So if we do this side, we're going to take, if we do the next example here, we're going to do the log of 3 to the x equals the log of 17. That x, using the property, comes down in front and is multiplied by the log of 3. Well, now I'm going to divide by the log of 3. Log of 3 is just going to be a number, but I'm just going to use my calculator here at the end. Now I take the calculator and take the log of 17, and I divide by the log of 3. So log 17 equals, and then I'm going to divide by the log of 3. And it's 2.5789 approximately to 4 decimal places. 2.5789. And you could test it on your calculator by taking 3 to that power. All right. These rules also apply to inequalities. I can't write 10 as a base of 5. So I can't get these in the same base. So that means you got to take the common log of both sides. So I'm going to do the log of 5 to the 3x is less than the log of 10 to the x minus 2. So just like with equations, you take the common log of both sides because we can't write them in the same base. Now this comes down in front. So I have 3x times the log of 5. This comes down in front also. So I have x minus 2. And I got to multiply that by something, so I need to put the x minus 2 in parentheses times the log of 10. So there's what I have so far. Now, here's what we need to do. Remember, we're going to use our calculator here. First, we're going to take, this is 3 times x times the log of 5. I'm actually going to multiply. Log of 5 is just going to be a number, so I'm going to take 3 times the log of 5 on my calculator. If I do that, 3 times the log of 5, so 3 times log of 5, do it on your calculator. I'm not going to pull up my calculator for all of these, but you could test it. 3 times the log of 5 is 2.0969. I'm going to go to 4 decimal places. Okay, so all I did was multiply 3 times the log of 5. Now, we still have this x here, so I'm going to put the x after it. Okay, over here, I'm going to find the log of 10. Now, if you do the log of 10, now remember that means the log in base 10 of 10, well that power is 1. This is kind of that inverse property. The log of 10 is 1. And if you go to the calculator here, if I do, I'll just prove it to you, the log of 10, notice it's 1. Because we're in base 10, that's the power on it. So if I come back over here, this is 1. Now, if that is something different than 1, we'd have to distribute. Now, distributing 1 just leaves me with x minus 2 there. Now, I'm solving for x. This is like 1x. I've got x on each side. Think about all the things you've learned with inequalities and equations. I got to get rid of x on one side. So I'm going to subtract 1x. So I'm going to minus 1x. So I get negative 2 over there, and this is going to be 1.0969 x 2.0969 minus 1. Now we're going to divide by 1.0969. Divide by 1.0969. Okay? Just remember with inequalities, if you ever divide by a negative, you got to reverse the symbol. If you actually do that on your calculator, negative 2 divided by 1.0969, we get x is less than. Now we can't really use our approximate symbol here because of the inequality sign, but I would round off to 4 decimal places, and I'm not going to do this one. You could test it on your calculator and do the division there, but you should get x is less than approximately negative 1.8233. So we're applying some logarithm properties here. We're taking some logs, going to 4 decimal places, algebraically getting x alone, okay, in equations or inequalities. So we're going to do the same thing here. We're going to take the log of both sides. So I have the log of 2 to the 7x power is bigger than the log of 3. Whoops. Not base 3 there. Let me erase that. It's the log of 3 to the 5x minus 3 power. This is very similar to the one I just did. This goes down in front, so I have 7x times the common log of 2. Over here, this comes down in front, so I have 5x minus 3 multiplied by the log of 3. Over on this side, we're going to have an x here. We can multiply the 7 times the log of 2. So let me pull up the calculator. Let's multiply 7 times the log of 2. So 7 times log 2, and that's about 2.1072. So 2.1072, that's times x, because we still have the x on it there. It's bigger than. Now, I'm going to find the log of 3, and then I'm going to distribute that. So let's find the log of 3. So log 3 is, whoops, did it twice there, 0.4771 about. So this right here is 0.4771 approximately. So I'm going to distribute that to both those. So I'm going to take 5 times 0.4771 and put that in front of x. So let's go ahead and multiply what we have in our calculator there. Times 5. We get about 2.3856. So we get 2.3856, and that's got an x on it because I'm distributing the 0.4, and then minus, and I have to take 3 times the 0.4771. And if we do that on our calculator, 3 times 0.4771, it's about 1.4313, so minus 1.4313. Now I have x on both sides, so I want to get rid of x on one side. Let's go ahead and subtract 2.3856x. So subtract 2.3856x. So I have negative 1.4313 on this side. And I'm going to go ahead and just, I have this in my notes, but if you do that on your calculator, that minus that, it's going to be negative 0.2784x, if you actually did that subtraction on your calculator. Now we have to divide by negative 0.2784 to get rid of it. Divide by negative 0.2784. Notice, we divided by a negative, we got to flip the sign. And if you do that division, and I'll let you do that on your calculator, but we should get about 5.1412, dividing those two negatives. So x is less than approximately 5.1412. All right, last thing here in this lesson, kind of the last topic, is the change of base formula. And here's what it says. If you look right here, if we're dealing with a base other than 10, we can't use our calculator unless they give us the approximate logs and things like they did in the last lesson. So we want to be able to change it to base 10. So when we say the change of base formula, we're going to get it so that we can use our calculator. Here's what it says using variables. Okay. if we have the log of n in base A, we're going to change it to the log of 10 in base n. Okay, they have a b there, but we're going to change it to base 10. So if you look here, here's kind of a numeric example. Well, this hopefully will make more sense to you. If I have the log of 12 in base 5, or the log in base 5 of 12, notice we're changing to base 10. It's the log of 12, which is this bigger written number, divided by the log of the old base. The log of the original number divided by the log of the old base. There's what it says. So if we do that and apply that to this, this really says I want to take the log of the bigger written number and I want to divide it by the log of this base right here, which is the log of 2. So if I do that, let's take the log of 20, divide by the log of 2 on our calculator. So log 20 equals divided by log 2, 0.43, or 4.3219. 4.3219. There's what it's approximately equal to. This one would be the log of 18 divided by the log of the base, which is 3. Okay, if you do that, I'm not going to pull this one up on my calculator, it would be 2.6309. Now, keep in mind, if they give you one like this, just to add one example here, if you want to write this one down, if I said, what's the log of 3 in base 5, that would be the log of 3 divided by the log of 5, and then you could do it on your calculator. So it's always the log of the base has to go on the bottom. Sometimes that base could be a bigger number than this right here. So if we actually did this, the log of 3 divided by the log of 5, let's go ahead and do that. Log 3, I'll hit equals divided by the log of 5. So that would be about 0.6826. So about 0.6826. So I always say it's the log of the bigger written number divided by the log of the base. It doesn't always mean the log of the bigger number, depending on what the base and that original number were. So just keep that in mind as you're doing this. And that's it for Lesson 10.4.